Okay, let's just dive right in. You know that moment in an exam? Your heart is pounding, you're staring at one of those factorial design graphs, and you're thinking, how on earth am I supposed to describe this? Yeah, if that sounds familiar, you are in exactly the right place. We're going to turn all that confusion into some serious confidence.
I mean, you know the feeling, right? You see something like this tangled web of lines and dots, and you can just feel that little bit of panic start to bubble up. It looks like some crazy, complex puzzle, and all you can hear is the clock, just ticking away.
But what you need to produce is, well, this. A super clear, precise, full-credit paragraph that just nails the description of the results. I know, it looks tough, but I promise you there is a formula. A simple one. And today, I'm going to walk you through it, step by step.
So, first things first, let's kind of reframe the problem here. This isn't really about super complex stats. Think of it more like a translation task. Seriously, every single one of these graphs tells a story, and your job? You're just the narrator.
And if you're going to be the narrator, you need a way to decode the story, right? Well, here is your secret decoder ring. We're going to use this really simple method I call the 3-point scan. Just think of it like a checklist, you know? It makes sure you never ever miss a key piece of the plot. It's super reliable, it's easy, and honestly, it works every single time.
So what is the scan? It's just 3 steps. That's it. First, we're going to check for a main effect of the first independent variable. Second, you guessed it, we'll check for a main effect of the second independent variable. And third, and this is the one that really trips people up, we're going to check for an interaction. That's the whole thing. 3 simple steps to a perfect answer.
All right, enough talk. Let's actually put this thing into practice. We're going to start with a really straightforward example, just to see how the 3-point scan works when the story is, nice and simple.
Okay, so here's our first case study. The big question is, does caffeine's effect on your reaction time change depending on the time of day? So our first independent variable, we'll call it IV1, is caffeine. Pretty simple. You either get it or you don't. IV2 is the time of day, morning or evening. And what are we measuring? That's our dependent variable, reaction time. It's in milliseconds, and remember, with reaction time, lower numbers are better. They mean you're faster.
All right, step 1 on our checklist. Is there a main effect of caffeine? So to figure this out, we're going to totally ignore the time of day for just a second. We're only looking at the overall averages. Those are called the marginal means. So, on average, the people who got caffeine had a reaction time of 260 milliseconds. Compare that to 310 for the folks who didn't get any.
So is there a difference there? Oh yeah, absolutely. 260 is way faster than 310. So the bottom line is, yes, there is a clear main effect of caffeine. On average, it just makes people faster. Boom. Check 1 is done.
Okay, on to scan point 2. Is there a main effect of time of day? We're going to do the exact same thing. We look at those marginal means, but this time from morning versus evening. So the average for the morning is 275 milliseconds, and for the evening, it's 295.
Are those numbers different? Yep, they sure are. So we've got our second answer. Yes, there is a main effect for time of day. On average, it looks like people are just plain faster in the morning. All right, 2 checks down, only 1 to go.
And now for the big one, the one everyone gets nervous about. Step 3. Is there an interaction? I know this question sounds really complicated, but it's actually asking something super simple. All it's asking is this: does the effect of caffeine depend on whether it's morning or evening? And the easiest way to see this, visually, is to just ask one thing. If we were to graph this, would the lines be parallel?
Well, let's take a look. In the morning, caffeine gives you a 50 millisecond boost. And in the evening? It also gives you a 50 millisecond boost. The benefit is exactly the same. So the effect of caffeine does not depend on the time of day. And that means, you got it, there is no interaction. The lines would be perfectly parallel.
Okay, so that was the nice, simple case. Pretty easy, right? But what happens when the story gets a little more complex? Let's run our 3-point scan on a brand new study, one where the variables actually do influence each other. So this time, we're looking at how study method, so flashcards versus just rereading, and class difficulty, easy versus hard, affect your exam scores. Now, spoiler alert, if we were to run the first 2 checks, we'd find main effects for both. But honestly, that's not the most important part of the story here, not by a long shot. So let's just jump right to the interesting part. Scan point 3. Is there an interaction? We'll take a look at the pattern this data would make on a graph. The lines are definitely not parallel. In fact, they spread apart, they diverge. That visual cue of lines that are not parallel, that are crossing or spreading apart, that's like a giant flashing sign that screams, interaction.
So what does that actually mean? Well, an interaction just means that the effect of one of our variables depends on the level of the other one. Let's make it real with the numbers. In an easy class, using flashcards gives you a little 5-point bump. But in a hard class, flashcards give you a whopping 15-point advantage. See? The benefit of using flashcards totally depends on how hard the class is. That is the interaction right there.
Okay, awesome. We've used our 3-point scan, we've analyzed the data, we've found the story. Now comes the final crucial step. How do we translate all of that into that perfect A+ written answer?
And guess what? Just like we have a scan for analyzing, we have a template for writing. It's so easy. When you find an interaction, you don't just say it's there and walk away. Nope. You start by saying there is an interaction between whatever your first variable is and your second variable. But then, and this is key, you have to add the magic word, specifically, and then you describe the pattern.
And using this template is incredibly simple. We just plug in what we found from our last example. It would look like this. There is an interaction between study method and class difficulty. Specifically, the advantage of using flashcards over rereading was much larger in the hard classes, where it was a 15-point difference, than it was in the easy classes, where it was only a 5-point difference. See? It's literally just filling in the blanks.
Okay, now let me give you a heads up on the single biggest mistake people make. They'll correctly identify the interaction, write, "there's an interaction," and then just stop. That is only half the answer. You absolutely have to explain what that interaction looks like. That's why that word specifically is so powerful. It forces you to describe the pattern. And trust me, that's where all the big points are hiding.
So let's just boil this all down into the key takeaways for your next exam. Number 1, always run the full 3-point scan. Don't skip a step. 2, main effects are all about the overall averages. Simple as that. 3, interactions are always about that it depends relationship. 4, use the writing templates. They are your best friend, I'm telling you. And finally, number 5, be specific. Use the actual numbers from the graph or table to back up your story.
At the end of the day, you have to remember that these graphs, they aren't just a bunch of random data points. They are stories. They're telling you how different things relate to each other out there in the real world. And the 3-point scan, it isn't just some cheap test-taking trick. It's the tool you use to read that story correctly. So the very next time one of these graphs pops up, don't panic. Take a breath and just ask yourself, okay, what story are you trying to tell me?